Our universe is teeming with an endless amount of asteroids, comets, and debris drifting through the interstellar medium. Sometimes, these objects drift our way for millions of years, and eventually, some find their way to us. In 2017, our solar system ran into an object lost in interstellar space. At first, classified as an asteroid, when it was spotted in 2017 traveling at 196,000 miles per hour. The object, dubbed Oumuamua, the Hawaiian word meaning scout, seemed to be long, thin, and cigar-shaped. Oumuamua was estimated to be about 1,300 to 2,600 feet, or 400 to 800 meters long, and was the first object ever seen flying into our solar system, orbiting around our Sun, while speeding up using the Sun's gravity to assist, a known maneuver called the orbit effect. A technique in which a spacecraft drops into a gravitational well, and after that, uses its engines to further accelerate as it is falling, consequently, attaining additional speed. The resulting maneuver is a much more efficient means to gain kinetic energy than applying the same impulse beyond that of the gravitational well. With this maneuver, Oumuamua, unlike the majority of solar system objects that orbit around the Sun, never leaving the celestial neighborhood, was instead fired back out once again into interstellar space. However, Oumuamua did not roll end over end like a typical asteroid, yet rather more like a wonky football pass. Additionally, close observations revealed it was gaining momentum, as if something were pushing on it, unlike any type of asteroid in the recognized solar system. Researchers, then only after that, classified the object as a comet. Yet, there was one essential problem with the comet theory. Generally, comets originate from regions much more distant from the Sun than asteroids. Moreover, they have ice on their surface, which transforms into gas as they approach the Sun, leaving behind them a trail of gas, or what we view as a beautiful comet tail. The outgassing of this ice modifies exactly how the comet maneuvers through space. It's a little bit like an extremely slow-moving rocket engine. The sunlight strikes the comet, the warmest part of the comet bursts with gas, and that gas flowing away from the comet sends it tumbling faster and faster away from the Sun. Oumuamua might have moved like a comet, however. When it orbited our Sun, it didn't have the traditional outgassing or tail, dismissing scientists' consensus that Oumuamua was a comet. An additional explanation, and also one that attracted a great deal of interest and objection when Oumuamua was initially discovered, is that the thrust from this object was an advanced propulsion system sent by a distant alien civilization, such as a light sail, a wide, millimeter-thin craft that accelerates as it's pushed by solar radiation. It is fairly feasible that another civilization, far more advanced, that had far more time for its technological growth and development, has actually developed this technology, and therefore, consequently, they are utilizing this probe to observe our world for possible intelligent life. However, most scientists still think Oumuamua's wonky acceleration is most likely the result of a natural phenomenon. Still skeptical, researchers involved in SETI, the search for extraterrestrial intelligence, made use of a powerful radio dish to scan, discovering no preliminary indications of radio signals or various other abnormalities, suggesting, nevertheless, Oumuamua had not been an alien spaceship, nor an advanced probe after all. Then lastly, just this June, a research team proposed that solid hydrogen was blasting undetectably off the interstellar object's surface area, triggering the object to accelerate. Explaining why there was no comet tail, as outgassing hydrogen wouldn't be visible from Earth, meaning it would not leave behind a visible comet tail. Indicating this interstellar visitor had to be hydrogen ice. The proposal of hydrogen ice appeared correct, explaining the exceptionally elongated shape of Oumuamua, in addition to the non-gravitational change in velocity. However, currently, scientists are once again backing away and retreating from this theory, due to the fact that the new alternative, the non-alien explanation, may actually be fatally flawed, as shocking new research suggests. The newly published study, in the astrophysical journal Letters, has stuck a knife into the idea that Oumuamua is made of molecular hydrogen ice, with its basis on the presumption that H2 ice could form in dense molecular clouds. The most likely place to make hydrogen icebergs remains in the densest environments of the interstellar medium. If this holds true, H2 ice objects could be abundant in the deep space of the cosmos, and therefore would have significant far-reaching ramifications. H2 ice likewise was also proposed to explain dark matter, a mystery of modern-day astrophysics. Yet, more than not, these theoretical hydrogen icebergs could not endure the long journey throughout interstellar space. Even starlight in the coldest regions of space would heat up small portions of solid hydrogen before they could clump together and form a hydrogen iceberg of Oumuamua's immense scale. As well as, more importantly, the trek from the nearest giant molecular cloud, a dusty, gassy region of space, where hydrogen icebergs are assumed to form, is far too expansive. A hydrogen iceberg traveling hundreds of millions of years through interstellar space would certainly have broken apart, cooked by starlight. Despite this fact, researchers still claim there is still an outside possibility that the H2 ice hypothesis could stand correct. Thankfully, if this H2 ice hypothesis is correct, then the Vera Rubin telescope will discover even more objects, as well as it will find them in time for the structure of their makeup to be far better determined. One of the most concerning issues for the H2 ice hypothesis is merely whether or not the dense cores of molecular clouds can actually get cold enough for H2 to begin accreting onto the larger grains, with temperature levels needing to get down quite close to the temperature of the microwave background for the process to function. The home of Oumuamua's origin is still a mystery. It appears to have come roughly from the direction of Vega, in the constellation Lyra, though some have actually suggested it might have originated from the giant molecular cloud, W51, 17,000 light-years from Earth. Nonetheless, researchers claim that is most likely not the case, and they have not had the ability to pinpoint the origins of the object entirely, which would be difficult if not impossible. Barely moving when it arrived in our Sun's gravity well, which makes tracking the comet through space challenging. Yet, researchers have looked at what else might have traveled through the Milky Way galactic neighborhood that our Sun is now currently passing through in recent cosmic history. They arrived at two groups of young stars, the Carina and Columba moving groups, that formed around 30 million to 45 million years back, in a cloud of gas that then dispersed. However, with the arrival of interstellar comet 2I Borisov in 2019 revealing just exactly how frequently these objects enter our solar system, as well as some of these objects even remain trapped within the Sun's orbit, enabling us to potentially someday rendezvous with one of these interstellar vistas, with a probe of our own, allowing us to gather samples and better understand these objects' composition and where they might have originated from. A mission that could be accomplished with today's technology. But where Oumuamua originates from, or what it is composed of, may never be known, as it is no longer observable with our telescopes. Yet, looking to the years ahead, it's obvious that we stand to learn a great deal more about these interstellar visitors, our solar system, exoplanets, the galaxy, and the universe as a whole. Thanks to next-generation observatories, robotic spacecraft, and humanity's long-awaited return to the moon, there is no shortage of opportunities to expand our knowledge of the cosmos, and our place in it. So, what do you think Oumuamua is? Has a distant civilization far more advanced than our own, with the same thirst for exploration, and the technology to accomplish the long journey across interstellar space, observed our world? Are they right now finding out for the first time, they are not alone in the universe? Comment below, and let me know your thoughts, and reactions to this interstellar traveler. And if you liked this video, be sure to click that subscribe button, for more interstellar happenings.